So we're going to go over your homework. So this is going to be a really long video. And so if you want to just skip to whichever problem that I'm going to be talking about that you need help with, you can do that. So you don't have to watch the whole thing. Alright, but I'm just going to start at the top and work to the bottom going through the problems. So the first one says write the formal charge for each element in the molecule. So for all of these H's right here, each one of those H's, we can see that H, if we look at our equation, I wrote the equation up here at the top. If we look at our equation, we're doing the number of valence electrons minus the number of valence electrons in the molecule. So each of those H's only bonded to one thing, so we can do them all at the same time. So normally they want one valence electron. We minus it by the 1. If you remember, we talked about before, in these bonds, there's like 2 valence electrons, and we're only going to say that H is going to own one of those. Since it's sharing, we only include one of those. And so it does 1 minus 1 to get 0. So H does not have a charge on it. Then let's do this C. So this will be C number 1. So a little 1 by our C. Normally C is going to have 4 valence electrons. If we count the valence electrons in this one, you'll notice it has 1, 2, 3, 4, 5. 5. So 4 minus 5, so it's going to have a negative 1. So this C is actually going to have a negative charge on it. Our next C, you'll notice here, we'll do number 2 by it. So this is C with a 2. Normally it wants 4 valence electrons. It actually has 1, 2, 3, 4. 4 minus 4 is 0, so no charge on it. Alright, we go up to our number 1 oxygen at the top. Normally, oxygen wants 6 valence electrons, so 6 minus 1, 2, 3, 4, 5, 6. 6, so that's perfect, as a 0. I'll fill in the extra valence electrons here for you, so that you know. So now we're on to our second oxygen. Our second oxygen, it has 1, 2, 3, 4, 5, 6, 7. So it has 6 minus 7, so it actually has a negative 1 charge as well on it. Oh, oops, sorry, let me erase that. I also forgot that we have this N at the beginning. So let's do the N that you can find right here at the very beginning. So that N, normally it would want 5 valence electrons. We'll notice in this it has 1, 2, 3, 4. So 5 minus 4 and equals 1. So it has a plus 1 charge, alright? So your N should have a plus charge. Your C right here should have a minus charge. And your O should have a minus charge. Alright, next one over here. Let's label these O's 1, 2, and 3. So our first O, O's normally want 6, so we'll do 6 minus, it has 1, 2, 3, 4, 5, 6, so it has no charge. Our second O, it wants 6, it has 1, 2, 3, 4, 5 around it. So 6 minus 5, that equals 1. And our last O has 1, 2, 3, 4, 5, 6, 7. So 6 minus 7, and it has a negative 1 charge. So this O has a positive 1 charge, this O has a negative 1 charge. That's what you should be getting in your problem. Alright, you don't have to highlight yours, I'm just kind of showing you where we're getting these numbers from so that you can see. Alright, our final one, you'll notice that all of these O's in this problem are all O's that have 6 valence electrons bonded with something. So we're going to do them all at the same time, because each of these O's are the same thing. So the O's normally want 6 valence electrons. They have 1, 2, 3, 4, 5, 6, 7. So they have a negative 1 charge. Again, you could do it like this one, 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 3, 4, 5, 6, 7. Alright, so we're just doing them all in one go. Negative 1 charge. So there's a negative charge on each of these O's. If we've got our Cl, it normally wants 7 valence electrons. It actually has 1, 2, 3, 4, 5. So it has a 2 charge, a plus 2 charge. So plus 2 by that Cl right there. And so all of these ones are actually going to have a charge on it, and you get that information from here. Alright, let's move on to Lewis dot structures. So, with your Lewis dot structures, we need to remember to put our thing that wants to be bonded with the most elements in the center. So if we look at our dots for H and S, you'll notice that H wants to make 1 bond, whereas S wants to make 2 bonds. So our S is going to go in our middle. S wants to make 2 bonds, and we can see that we have 2 H's. So that works out really well to put our H's right here. We also know there needs to be 8 valence electrons around our S. So S is going to have 2, 4, 6, 8. Alright, we also forgot to do our valence electrons at the beginning. So this problem is going to have 6 plus and then this is going to be 2 times 1. So it's going to have 8 valence electrons. So let's make sure we have 8. So we have 2, 4, 6, 8. So this is your structure for that H2S. All right. Next one, the CH3O minus. So let's do our valence electrons to start off. So we have 4 plus, actually let's do it this way. I think it'll be less confusing. So we're going to do 4. That's for our C. Our H wants 1, but it's going to be times by 3 because there's a 3 there. And then our O is going to want to have 6. So if we add all those up, we'll get 13. We also have a negative 1 here. So we have to add one more electron because remember they're negative, so you have to add one more. So it's going to be 14 valence electrons. So for this structure, let me switch a little bit of a thinner one. So we know our C valence electrons, it wants to make 4 bonds. With our H, it just wants to make 1, and our O wants to make 2 bonds to not have any charge on it. Now we know that this has a charge on it, so that means one of these is not going to make the right number of bonds, but let's see if we can figure that out as we go. So again, start with C as your middle. It wants to make 4 bonds, so we have 3 H's, so let's bond it to the 3 H's. It wants to make 1 more bond, so let's bond it to an O. Alright, so we'll notice that our C has 2, 4, 6, 8 valence electrons around it. Our oxygen right now just has 2 around it. So we need to add 4, 6, 8, so it will follow that rule of having 8 things around it. So now you'll notice that oxygen, remember oxygen normally wants to have 6 valence electrons around it to not have a charge. This oxygen actually has 1, here let me use the red thing. It actually has 1, 2, 3, 4, 5, 6, 7. So since it has 1 extra, your oxygen is going to have the negative charge by it. We can count to make sure that we have the right number of valence electrons in the structure. We have 2, 4, 6, 8, 10, 12, 14. So that works out there. So this is your structure for that one. Alright, let's move on to the CF4. So again, carbon usually has 4 valence electrons. F normally has 7 times by 4. So that's going to be 28. So this is going to be 32 valence electrons for this one. Alright, so we know carbon wants to make 4. Our F, if we draw that one, it wants to make this one bond right here because it has 7 around it. So we're going to put our C in the middle. It wants to be bonded to 4 things, so we're going to bond it to 4 F's, because we have to use 4 F's anyways. Now our F's, right now our C has 2, 4, 6, 8 valence electrons around it. Each of these F's only has 1 bond, so it only has 2 valence electrons. So for each of these F's, we have to add 6 more to get to 8. So add 6 more to each of these, and then we'll see if our electron count is okay. Alright, so we added 6 to each of those. Now let's count to make sure we can get to the 32 number. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we had 32 in here, which matches that. So this is our structure. Alright, NH4+. So this is similar to that minus problem, except it's a plus, so we're going to have to be adding in or taking away electrons. So we normally have N, which normally has 5 valence electrons. We have H, which normally has 1, but we have to times it by 4. So it normally have 9, but since it has this plus charge, that means we're taking away an electron. So this is actually going to have 8 valence electrons when we're done with it. So if we look at our N Lewis dot structure and our H Lewis dot structure, we see our N wants to make 3 bonds. So we're going to put our N in the middle. Now, we know it has a plus charge here, so we know that our bonds aren't going to, that something's not going to be bonded to the amount we think it would be bonded. So let's start with bonding our N to 4 different H's. Alright, so we have our N bonded to 4 different H's. You'll notice N has 2, 4, 6, 8 electrons around it, so it's good. But if you think about before, how N just is owning only one of these electrons. When we do our formula, N normally wants 5. It only has 4 around it. 1, 2, 3, 4. So it's going to have a +1 charge. So that's good for us because we wanted it to have a plus charge. So you put a plus charge on the N. Now we can make sure that we add up to 8 valence electrons. 2, 4, 6, 8. So 8 valence electrons. So this is your structure for NH4+1. You might have to try lots of these several times, but that's okay. You'll get the hang of it as you work on them. Alright, so we have C4H10. So carbon normally wants 4, and it's times by 4, so that's going to be 16. And hydrogen normally wants 1, but it's times by 10, so that's going to be 10. So 26 is our goal here. So, we always want to start with the thing that wants to bond with the most things in the middle. So we're going to do our carbons just all in the middle, bonded together to each other. Alright, now we need to make sure that each carbon has 8 valence electrons around it. Right now, like this one only has 1. So it needs to have 8 other valence electrons around it. So let's bond it to H's. This carbon in the middle has 2, 4, so it has 4. So it needs to be bonded to other, so we can get 2, 4, 6, 8. You see how we're doing that? This one has 2, 4, 6, 8 on this side. So now let's make this one, the next one have 8. So it has 2, 4, so 6, 8, and this last one has 2, so 4, 6, 8, bonded to H's. Now if we do that, let's make sure we have the right number of H's. So we need 10 H's. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's perfect. So let's just check to make sure we have 26 valence electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this works out because we have 26 valence electrons there. It says we need 26, so this is your structure. There are a couple other ways you can draw that, but that's the structure that I'm going to draw. You can submit yours, and I'll tell you if it's right or not. All right. Next one, NO3 minus 1. This is probably one lots of people had problems with. So let's look at this. So we have N, it wants 5. We have O, it wants 6 times by 3, so it's going to have 18. So total, we're going to have 8, 9, 10, 11, 12, 13, carry your 1, so 23 valence electrons. So if we look at our N Lewis dots and our O Lewis dots, we know that N wants to bond with 1, 2, 3 things, while O only wants to bond to 2 things. So let's put our N in the middle, and let's bond it with our other O's. Alright. So, there's lots of you who might do trial and error to figure this one out. I'm just going to tell you that we need a double bond in this one. We have a -1 here, so we're going to make our nitrogen double bond with an oxygen. Now, we'll see that nitrogen does have 2, 4, 6, 8 around it, so nitrogen's done. This oxygen has 2, 4 around it, but it still needs 6, 8. Now this oxygen has 2, so it needs 4, 6, 8 electrons around it. This oxygen has 2, so it also needs 4, 6, 8 electrons around it. Now we need to figure out where our charges go, because we have a negative charge. So let me draw in these little electrons on the ends of the bonds, and we'll count how many things have charges. So we have our nitrogen, which has 1, 2, 3, 4 things. So your nitrogen normally wants 5, but it has 4. So that means our nitrogen is going to actually have a plus charge on it. Now, let's look at this oxygen on this side, okay? So that oxygen, normally oxygen wants 6. That oxygen has 2, 4, 6 around it. So 6 minus 6 equals 0. Now these other 2 oxygens, they look kind of the same. They both have 2, 4, 6 around it bonded with a nitrogen. 2, 4, 6 around it bonded with a nitrogen. So we're going to do those together. So those oxygens, they normally want 6. If we count up how many they have they have 1, they have 1, 2, 3, 4, 5, 6, 7. This one also, 1, 2, 3, 4, 5, 6, 7. So they have 6 minus 7, so that's -1. So both these oxygens have a negative charge on it. Alright, so that's how you do that one. It just takes some trial and error. I think a good hint is that if you're not getting them, to add a double or triple bond and see if it will work out. Alright, AlH3. This one is a little bit of a weird one. So if you have Al, you'll notice that it only wants to make 3 bonds. So Al is going to be one of your things that's not going to follow that rule of having 8 things around it, because it's only going to make 3 bonds. So for this one, you have Al, and it's being bonded to 1 hydrogen, 2 hydrogen, 3 hydrogen. There won't be one that's hard on your test that won't follow the rules, but I just want you guys to be aware that there are some that don't follow the rules, but this will be your correct structure for the AlH3. Okay, there's your correct one for NO3. Alright, O2. So O has 6, there's 2 of them, so we need 12 valence electrons. We also know that O looks like this, so we want to make 2 bonds. So we're going to have O. It's going to be bonded to another O. Now, O needs to make 2 bonds for it not to have a charge on it. This O does not have a charge on it. So O needs to bond with itself again and form a double bond to not have a charge. Now, each of these O's only have 2, 4 electrons around it. So we need to make sure that they have 6, 8. So we need to add 4 more electrons to each of these O's. Then that can help us count up to see if we can get to 12. So we have 2, 4, 6, 8, 10, 12. So we're going to have 12 valence electrons. So this O structure matches that. So this is your correct O2 structure. That's actually what you're breathing in the air is O2. Alright, this CO3 minus 2 is also a really tricky one. So we know that carbon wants to make 4 bonds. Oxygen wants to make 2 bonds without having a charge. We have a charge, so we know that our bonds aren't going to be exactly how many you would imagine. So we'll have carbon usually has 4 valence electrons. Oxygen normally has 6 times by 3. So we have 18. So we're going to have 22. You notice that we have a negative 2, so we actually have to add 2 extra electrons. So 24 is what we're going for. So carbon wants to make the most number of bonds. So we put carbon in the middle. Let's just bond it with some oxygens. Alright, so we know carbon needs to either have a lone pair here, or it needs to bond again with another oxygen. Because remember, we always need to have 8 valence electrons around it. This carbon only has 2, 4, 6 around it. So let's just add on a double bond, okay? Add another double bond there. Then let's make sure each of our carbons, we have our carbon that has 8 valence electrons around it. Let's make sure that each of our oxygens have 8. So this oxygen has 2, 4. So we need to add 6, 8 around it. This oxygen just has 2. So we need to add 6 more to get to 8. This oxygen on this side just has 2. So this one needs to add 6 more to get to 8. So we need to figure out where our charges go. Carbon normally wants 4. It has 1, 2, 3, 4. So that works. Oxygen normally wants 6. This oxygen has 1, 2, 3, 4, 5, 6. That works. Let's look at this oxygen. It wants 6. It has 1, 2, 3, 4, 5, 6, 7. So this oxygen down here, it wants 6. It has 7, so it has a -1 charge. You can also look at this oxygen up top, and it has 1, 2, 3, 4, 5, 6, 7. So it's again 6 minus 7, and it gives us a negative charge by it. So that's where you get your -2 charges. We can count up our number of electrons to make sure we equal 24. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 24 valence electrons with a -2 charge. So that is your structure. Alright, 3 more. Stay with me. Alright, this last one, over on this bottom side, we have hydrogen that wants 1 valence electron. We have carbon which wants 4, and we have nitrogen which wants 5. So we add those all up, we get 10. We need 10 valence electrons. You know your carbon. Remember, your carbon wants to make 4 bonds. Oops, sorry. So your carbon wants to make 4 bonds. Your nitrogen only wants to make 3 bonds. So your carbon, we're going to put that one in the middle, and we're going to bond it to hydrogen and to nitrogen. Now you'll notice that right now carbon only is making 2 bonds, and nitrogen is only making 1 bond. And so let's add in bonds to make it so that carbon is bonded to 4 things and nitrogen is bonded to 3 things. So if we add in this and make this a triple bond, then we can see that carbon is now bonded to 1, 2, 3, 4 things, and nitrogen is now bonded to 3 things. Now carbon has 2, 4, 6, 8. You can see this 2, 4, 6, 8 valence electrons around it, so that works. Nitrogen just has 2, 4, 6 around it, so we need to add in a lone pair to make it have 8. Now we can count up our molecule to see if we can get 10 valence electrons. So we have 2, 4, 6, 8, 10. So we have 10 valence electrons. We have 10 valence electrons here. So that's what our molecule will look like. Alright, these next two are a little bit tricky, but hopefully yours will look something similar to this. So I'm not going to be drawing out the Lewis dot structures for CH and O. Hopefully you know those. We know though that we're trying to get to, let's see, 4 times 2 is 8. And then we're going to have 1 times 6 is 6. And we're going to have oxygen, which has 6. So we add up all these together. It should come out to about 20. So yeah. So about 20 is what we're getting. So we need carbons in the middle because carbons have bond to the most number of things. Let's bond these with some H's to fill in the extra bonds. Alright, and bond this to an O. So in this, we notice that we've used up 1, 2, 3, 4, 5 H's. We need to use one more H. So oxygen also has only made one bond. You remember oxygen wants to make 2 bonds. So this oxygen is going to be bonded to another H. Alright, you'll notice that oxygen right now just has 2, 4 electrons around it. It needs to have 8, so we'll do 6, 8. Alright, now we can count up our number of electrons. We get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We hit this 20 number, this is your structure. Again, yours might look slightly different, but as long as it has those similar connections, you should be okay. Alright, this last one, we want O to be our middle element now. So let's put O in the middle. Let's have it be bonded. Remember, O wants to be bonded to 2 things. So O is going to be bonded to 2 things. Let's just make them both carbon. Okay, so now we've used up our O, we've used up our 2 carbons, so now we need to use up 6 hydrogens. We know that oxygen is already bonded to 2 things. Carbon wants to be bonded to 4 things. So let's bond carbon to 4 things by adding 3 H's on each side. Alright, you also know your O in the middle, that it has valence electrons on it, because it only has 2, 4 right now. Right here, it only had 2, 4, so we need to add 6 and 8 to get to 8 valence electrons. Now this is also going to be 20 because it's the same molecule. So if we count that up, we get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is your correct structure for that one. Alright, I know it was a lot. I know we went a little bit fast. So if there's a specific one that you need help with that you couldn't understand the video, please reach out to me and I'll try to help you, or come in and get help. This might be one that you have to come into the classroom just to be able to ask questions and talk face-to-face with me about it. Good luck studying for your tests, and I'll see you guys soon.